What I wanted to ask, over on the questions first, your doubt if you do have any.
So I was
The other,
trying I couldn't get the first problem. I was trying the second problem. One way I thought was like if this is the disk, right? You could bring so basically you want to calculate the potential at the periphery. Right? So a potential is path independent. So I thought you could bring a charge from infinity to the center of the disk first, and
okay.
then move it from there to the edge. I calculated the potential at the center. I think you get a sigma r by 2 epsilon naught. But then I wasn't able to figure out how to calculate the potential from there to the edge. So another way I thought was to consider it sideways, like here's the disk, and then you bring the charge from infinity to the edge on the disk. So I was actually trying to solve using that process.
Okay, that's good enough. I do appreciate that will be a way out. That is one of the many ways that you may adhere to. But I would have wished you get me the end result on them. I'm not negating your precedence. That is good. And this precedence is to be continued. You have been continuing with it. I am really in praise, all praise, I would say, for them, for whatever you've been doing. The only issue with you, Asadev, is that you're getting somewhere down the line slightly dissuaded on continuance. So that you need to arrest.
Yes, I was
That's
actually
simple, but
working
you
on
have
it
to
when you
stay
called.
fast.
Like I was actually working on it, so I mean, yeah, I was halfway through it.
A lot on the plate, swamped, right?
Yes.
Okay. So why can't we do this way, Asadev? What can we do is that we can cut it into strips.
Strips like
But
which
what
like
kind of, yeah, so of course, what kind of strip we can cut into? We can cut an arc.
okay.
Wherever from you have to calculate, let's say you have selected a point P at which you have to calculate, fine.
Yes.
Then you will draw an arc of certain radius on the disk from that point.
Yes.
Can you do that? Will you execute it?
Yes, sir.
Let's take a point P. Let's take a point P.
1 second. In class. Come later. Well, I'll need it later. I'm in class right now.
Let's
Yes.
take a point P. Yeah.
So one thing, I'll just. You should be able to see it.
Sure.
Yes. Yes, sir. What were you saying?
Make the disk first. Draw the disk. Take a point P where we have to calculate any point P on the periphery.
Yes.
And now we can draw an arc of radius small r with this point at the center.
So I didn't get you.
A
What are you saying?
circle of certain radius r you draw,
Okay.
which will be an arc to this sphere. No, not sphere, disk. No, no, no. From point P, dear. From point P.
Okay.
These two form.
So arc of like this.
Yeah.
Okay. So how would that
Yes.
benefit?
It'll benefit, dear.
Yes.
Yeah. Stretch it up to the periphery.
Yes.
Now, how would this benefit? No, no, not small. I asked for any radius. You have taken specific radius.
Yes, sir.
Any radius small r.
Okay, sir. Just a second. Yeah. So that's the center. That's some radius,
Yeah.
and
Correct.
that's the circle.
Exactly. Okay. So we can draw. I can mark this as small r.
Yes,
Now
sir.
we'll take the thickness of this arc as dr.
Yes, sir.
Thickness is dr. We can write charge on it as sigma into whatever angle you take. Let's say we take 2 theta as the angle. So firstly the area will be r into r d theta into 2 theta if you have taken. So r into 2 theta into dr, correct?
So r d theta dr. Yes, sir. So if you're saying this is theta.
Yes. This multiplied with sigma will get you the charge.
Yes. Sir. So this wait 2 theta. Okay, this is the area. Times sigma is the charge. Yes.
Correct. Now, due to this, because all the points are at the same distance, we can write potential in one go. That
Yes,
was
sir.
the purpose.
Mm-hmm.
I want to write potential for a structure in one shot,
Yes, sir.
and it will facilitate it, right? 1 by 4 pi epsilon dq by r. We can write that down, correct?
Yes, sir.
Once you know potential, you can go for integration, dear.
Yes, sir.
Like, yeah,
So,
okay.
what do you say?
If I'm to go for integration, I'll vary small r, I'll have to vary theta as well. So there should be a relation between small r and theta, which we can get easily, right?
Yes, sir. Yes, sir.
Isn't it?
Yes, sir.
How will it facilitate? Tell me. How will you get it? If you draw a bigger arc, it'll be easier for us to see.
Yes, sir.
Arc which is greater than capital R. Small r, if you take greater than capital R.
It's kind of hard to draw it from this perspective.
I should-
Yeah.
Yeah,
Okay. Something like that.
that's right. Now, you can very well relate small r with capital R and theta, right, dear?
Okay, this is small r, that will be capital R, and that will be theta. Okay, the theta is obviously different.
Yeah.
This is theta. But this
That is
is.
capital R, the one
Yes.
that you've connected to C, and this capital R. So capital R, small r, and the angle 90 degree. You can take the angle 90, you can show the angle 90 degree
So,
by the diameter subtending what angle, or otherwise also you can relate now small r, capital R, and theta, right?
okay, this is small r. No, that's not small r. Oh yeah, that has to be small r. Okay, that is small r. This is capital R. That is theta. Right. How would you relate them?
That P, can you mark the point as A? Yeah, that point as A
Yes,
on
sir.
the periphery.
Yes, sir.
Now PA is capital R. PA is what distance for you? Small r for you,
Small r.
right?
Yes, sir.
Yeah. PA is small r, and we are having PO, if O is the center, as capital R, correct?
Yes, sir.
Now can we draw a right angle triangle here?
Like this.
No, 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 no. Okay, fine. Go ahead, go ahead. Sorry, go ahead.
So
You may. I was referring to, if you stretch this line, if you stretch this line, this which I'm referring to PO line.
yes, sir.
If you stretch this line and let that touch the diameter,
Ooh, like this.
yes, now you get 90 degree,
Like this.
right?
Like this
Yes,
one. That's 90.
yes, correct. That 90 degree. Now you related capital R with small r, right? Yeah.
Okay, wait. This is 2 capital R.
Yes,
Okay, yeah, but then you can just use the cosine rule. Yeah, okay, sure.
yes.
Yes, sir.
Got it.
Yes, so that'll be 2 capital R, that's small r, and then you can, well,
Now
yeah,
small
okay.
r is to be just replaced. That's it. Nothing much.
Yes, sir.
We can get in terms of capital R and theta, right?
Yes, and this is also capital R.
Yeah, that's capital R, but we are not using it.
Yeah, okay.
I presume we are not users, right?
Yes, sir.
So that was the idea, to get the relation between small r, capital R,
Yes, sir.
theta being related. After that, I'll write potential at that point, and then a mathematical manipulation, because you'll have to use over a product rule. You
Yes,
should be
sir.
aware of theta sine theta integration.
Yes.
Theta sine theta integration, if you're aware of, you'll be able to integrate this.
Yes, I'm not
There'll be a stuff
currently aware
akin
of
to
that,
C.
but I'll look it up.
Are you aware of? It'll just write it down. Replace for small r.
Sir, what is it?
Replace for small r in your equation for dq.
Um, it's replace for smaller? I don't,
Yeah,
I don't.
capital R and theta. You have capital R, you have theta.
Oh, okay, you want me to express smaller in terms of capital R and theta.
Yes.
Um, so, well,
You can
you have.
substitute
Okay,
like small r. You can write it down as 2 capital R cos theta is equal to small r, right?
yes. Okay. To capital R. Okay, cos theta is equal to small r. Sure.
Right.
From there, okay, so
Please.
dq is equal to 2r cos theta times 2 theta Okay, dr we'll have to differentiate this on both sides. 2r cos theta is minus sine theta is that's equal to dr. So this will be minus 2r sine theta and sigma of course is in the front.
We can
Yes,
write potential.
is it 2 sine? Yes, sir.
We can write potential now. Potential was to be gotten right.
Yes, sir. Wait, right now we have the charge on the strip. How would we use that to get the
But
potential?
1 by 4 pi epsilon cube by r for that strip. Just
Oh,
that
okay,
strip.
okay,
Every point
okay.
is at
All right, all right. We're treating each one of these as rings and then using the standard formula.
right, right, right.
Yes, sir. Okay. All right, I can do that.
You'll have a relation of the kind theta sine theta, the product rule. Are you aware of how to execute the product in integration?
So are you talking about integration by parts?
Yeah, no. I'm not against integration by parts. Yeah, I'm talking of the inverse of product rule, product differentiation.
So that's what's called integration by parts, right? Inverse of the product.
No. Integration by parts means you are dividing an equation in two parts and integrating them separately, right?
But like so the way
I'm
I
not.
studied integration of x cos theta for AP calculus, they thought it was integration by parts. So, yeah.
Okay. I know issues. The idea being, right?
Yes, sir.
Okay, so you can place the limit and see that the part which will be problematic or appearing to be not amicable will reduce to 1.
Yes, sir.
And you will be getting a sigma r by pi epsilon naught. That will be the answer.
Sigma r by pi epsilon naught. Okay, sir.
Yeah, it's an important derivation, very important derivation. Not everywhere we can, but very certainly we may be in a position to find. And this question is a tentative question in IITA. I may say it can appear in advanced examination, though it's very mundane now. It's being overdone, so they may tweak somehow. They may say that sigma is a function of r or anything of the kind.
Hmm.
Okay.
Yes, sir. So what about if you do it
So,
like this? If you
right.
took a general point here and then just use the potential, just use the definition that v is equal to 0 to infinity dot dl.
You used for potential at that point. It was a periphery. You have to find a periphery, right?
Yes, sir. So I mean, you find the general electric field at some point due to this ring in the plane of the. I mean, due to the. Okay, first you do it for a ring, then you integrate that to get it for a plate, right? So then you integrate that from 0 to infinity to get the potential at that point. Or does
But
that
the
sound?
issue will be there if it is conduct, you are talking of the case wherein there is no induction.
So, but it's a plate with a uniform charge density, right?
You're bringing a charge there. You want to find electric field there, but electric field will be function, right? Function of small r.
Yes,
How will
yes.
you measure electric field there?
So like first I would do it for a ring. So let's take a small dq, find that, and then integrate that for. I mean,
But
you'll
the
have to.
ring different point will be at different position, right, dear?
Yes, yes. I was actually
And
trying to work on that. You'll have to integrate it twice from here to here and from here to here because you can't do it in one go, right? Um,
okay,
because
okay,
for each angle you'll have two of these, one here and one here.
right, right. Yeah, it's possible, very much possible. In fact, I get your question on that. You reminded me of a question. There's a question that is being asked that there are two shells.
Yes,
You
sir.
have to find E1 dot E2 into dV. It's quite an interesting question.
So two shells, and
There are
what do you
two
have to find?
shells kept. There are two shells kept separated from each other and by large distance, very large distance. Okay, dear. Two
Yes, sir.
shells, and they're producing field at certain point in space. They are producing field E1 and E2 respectively.
Yes, sir.
So you have been asked to find what will be E1 dot E2 into dV integration of
So dv as in what would dv?
dV is volume, small volume.
Okay. So like e1 dot e2 dot into dv. That sounds like a very odd integral to
Yeah,
take.
E1 dot E2 vectors into
Yeah.
dV
Okay. So
integration.
over what volume? I mean, we haven't
Or
mentioned.
the volume outside, they are separated entire of the region.
Oh, okay. The entire the region between them.
Yeah.
Okay.
interesting question, and we need to comprehend what basically we are defining
Yes, sir.
and what the parameters, which is to set our answer.
Okay, sir.
Think about it, and think now itself.
Okay,
You can write that down. E1 dot E2.
yes, sir.
What was the other question which I asked you, dear?
The one about the cuboid and randomly distributed
Ah,
charges. And I
okay,
mean, we've
that's
got
very important.
resolve
Has
that
not
into a
been
dipole.
taken. Did you? Are you aware of how do we get it?
So no, I did
Because
try
that is a
it for a while,
concept.
but I didn't make any progress.
Hey, it's very simple. Come on, you'll get it. I'm sure you'll get it. Can you tell me what is the definition for P?
So P is
Dipole moment.
QD, charge times the distance,
2 into D.
or
So we
2A,
call that
usually they say.
product of charge and displacement. That is what's known to us, right?
Yes, and this goes from negative to positive.
So if I let you know that how do we get it, I'm sure you'll be able to figure it out on your own. Shall I let you know that it is not that we decide on P that'll be Q and D product. It's not that. What exactly it is, Vasudev, which you may not be aware of. That is the only chink in the armor. You'll be able to solve all the questions related to dipole, whatever be the configuration once this is known to you. We don't do Q into D. What we do is product of charge with their position vector and add them. That's it.
So could you come again? Product of charge with that position
Product
vector,
of
and you add them.
charge with their position vector and we add them. Do it for the dipole, you'll get the result as Q into D.
So if this is plus, sorry, this is minus q and this is plus q. So you're doing minus q r1 plus q r2. So you're saying this is the dipole moment?
Yes, this is the dipole moment. That is the definition. It's not that I'm saying.
Okay,
That is
yeah.
the definition of dipole moment.
R2 minus R1. Okay, it does seem to be getting into there. R2 minus
That is how
R1.
we get. Otherwise, why will we define a term? What is the idea behind of defining it certainly is to write amicably torque and potential energy equation, right?
Yes,
But then we are defining it with a baggage. We are carrying a baggage of it actually is product of charge with position vector.
yes,
And then the addition.
yes. Okay, okay, this is interesting.
Yeah, very interesting.
Yes,
Now you know what to do, right?
yes,
And
sir.
of course, it'll not depend on your reference. That also you can very well make you are an astute, right?
Yes.
It does not depend on reference. Eventually, we are what are we doing to eventuating? Just think about it. We are finding difference of two vectors, correct?
Mm-hmm.
The difference
So,
will be independent of any reference.
yes, sir.
So on cuboid or cube, whatever is given to you, you can take any point. It'll end up getting you the same result when you sum them up.
Yes, sir.
And so this was the other concept which I want to highlight. Now this one which I'm asking you, Vasudev, basically think first you think about it.
So, two spheres and separated by a large distance. Well, let me just draw. Okay, there's one sphere there. And there's another sphere there. Large enough distance. Yeah, so what was the next part of the question?
Find epsilon naught E1 dot E2 integrated dv integration for
Yes.
the space open area out of the two spheres.
So what's the limits here?
You can take it from R to R minus. Actually, it is based on volume present other than occupied by the spheres.
Or is it like this is on all space?
Yeah, all space.
Like everywhere from here to like infinity?
Yeah, everywhere. The point where you're getting E1, E2, you can take an arbitrary point there. You can show that shell A is producing field E1 and shell 2 is producing E2.
Yes, and both of them have like the same charge or different charge? Oh,
Uh, that's field given to you that's there. May not be necessary that they are having same charge. May not be necessary they are of same curvature either.
So how do you? I mean, okay.
They're they're far. Anywhere you take in between, somewhere in space between, not inside of it, outside.
Okay, so
Outside.
they're far
Outside.
enough apart to avoid induction, right?
Yes.
Okay, so that okay, all right. So if you take any point,
Take any point.
all right, if this
One, you
is
do the first one, you do the second one. You don't show any direction.
sphere one, you'd get this way. That's E1. Sphere two, you'd get this way. That's E2. Okay, this is a very general problem. E1 dot E2. I mean, sure, there's an angle between them. I mean, where do you go from there?
Interesting question.
Okay. Um, okay. Even if, how would you go about considering volume elements?
Because we are aware of something which you did ask few days ago, and I told you that it can be related to energy per unit volume. You asked me about electrostatic pressure,
Uh,
sigma square by twice epsilon naught, and I had an idea at the time, which I did ideate, that we'll be proving in days to come. This is nothing but energy per unit volume, or for that matter, stress.
yes, sir.
We have same equation for them. It's pretty simple to realize, dear. Energy per unit volume. What will it be? Half epsilon naught E squared. Correct. Are you
Um,
aware of this one? No.
yes, sir. I think this comes somewhere in capacitance. Like
It
when you.
does.
Yes, sir.
Yeah, it does. But you are aware of that this sigma squared by twice epsilon naught is nothing but pressure or stress. Correct.
Yes, sir.
So we can integrate it over area and we get energy. You'll be getting the same relation, which you can later write as sigma squared by twice epsilon. You can take a shell and you can see for yourself, no issues. It's true that generally we take it after of the electrostatic, it is easier then. Why? We write half CV square and accordingly divide by the area, which is A into D.
Yes,
Okay,
sir.
that'll be easier. Of course, it'll be easier. But we are aware of pressure, we are aware of stress, so we can very easily find energy. Any point you take, you can write force, force multiplied with area, correct?
Yes, sir.
See, I'll give you a very simple example. We know force on the surface of a shell, right? Sigma was the field. Field will be sigma divided by twice epsilon naught, correct?
Yes, sir.
Okay.
Sigma
And then
divided by epsilon naught on the outside, zero on the inside. You
not
take that
outside,
average.
because I'm calculating force, right?
Yes, sir.
On it.
Yes, sir. But like the way that hot is, I mean, I think I learned this part from I think Walter Lewin's lectures on YouTube. So
Okay.
basically, what he had to say was it's sigma over epsilon naught just outside, and
Yeah.
it's zero on the inside. So essentially, I'm in class, please. In class, you can come later. Right, give me the mangoes. Right, just
Rest,
mangoes. Okay,
rest of the
sigma.
structure.
Yes, sir.
Yeah. Right. Carry. Right?
So sigma by epsilon naught on the outside, zero on the inside,
Correct.
and so like on the surface, it would be their average. So sigma over two epsilon naught.
I would not prefer this average. Why? Because this is a method which may land you in soup if there is tweak on sigma.
Hmm.
What I would suggest is, why don't we write the way that we take in class? We have taken this in class. I suggested that you take inside and outside because of delta S to be different, but rest of the structure will remain same.
Yes, sir.
And from there you will be able to extrapolate that it is sigma divided by twice epsilon naught if you don't take, if you puncture it.
Yes, sir.
If you remove delta S, then that part is off.
Yes,
So
sir.
for the rest of the sphere, it will be sigma divided by twice epsilon naught. Anyway, whichever way is comfortable to you. As
Yes,
of
sir.
now, I will not ask you to change of what you have generated a perception. So let be sigma divided by twice epsilon naught is what we are getting, right?
Yes, sir.
Okay. In that case, are we in a position to find what will be force on a small area delta S,
So like this
right?
is the electric field.
Correct.
Um,
multiplied with charge on the area. Sigma into delta x we can take as charge on the area.
Sigma dA will give us the charge
Yes.
times this is the electric field, so this should be the
Correct.
force.
Yeah, this is force. And let it get displaced by some distance here to get me work. And this is work done by field, correct?
Yes, sir.
Is work done by field. Field is doing work, so potential certainly will decrease, right?
Yes, sir.
Now we can find energy per unit volume. What volume must have been incorporated? What volume, where is this energy being stored? What volume was initially having energy, but as you have expanded it, then that energy is a miss. That energy doesn't exist because we know energy is housed by field, correct?
Yes, sir.
So there was a small area which was, when the shell was not expanded, then there was a small area which was entailing energy, which was housing energy.
Yes, sir.
But as you did expand, then that area with which some volume can be ascertained, we can mark it as S into dr, right? S into dr will get me volume.
Yes, sir. A little bit expansion.
Yeah.
This
So
amount.
that area is now bereft of energy.
Yes, sir.
That energy got lost, right?
So initially it was like this, and now it's just like this. No
Yeah.
field here.
Yes. Right.
Yes.
Getting it?
Yes, sir.
So we can for that area calculate work and divide by volume. Work you have calculated already, right? This is work for you, correct? The
Yes, sir.
one that you have written. Let's divide by volume. So S into dr, can we write it down as S into dr? Yeah, dA. Okay.
So with
Now
this
dr, you can see for yourself what you are getting.
sigma squared over 2 epsilon naught. Yeah, sure.
Yeah.
Yes, sir.
And this you can write as half epsilon naught E square because we are aware of what E is for a shell.
Half epsilon naught E squared. So what's E?
Yeah, E square. E is the electric field.
Oh, yeah, right.
Yeah.
Okay. So wait, how did we jump from sigma to E?
Okay. Why did we jump from sigma to E? We wanted to write in terms of E. If there is a change in electric field here owing to medium changing, let's say I'm changing the medium, owing to changing of medium electric field changes, then you get it as half K epsilon naught and E will change to E naught by K.
Yes, sir.
I want to bring in that factor. Let's say that this is vacuum. Now I want to do for a medium with dielectric constant K. What you'll be getting then is half K epsilon naught E
Yes, sir.
naught by K whole square.
Okay, so epsilon naught will get replaced by K
Yeah,
epsilon
by
naught,
epsilon. Epsilon
and
naught will get replaced by epsilon and E naught will get replaced by E.
yes, sir.
Got it?
Yes, sir.
Okay, and by the way, this brings me to another important question. Do we have any differential vis-a-vis understanding on dielectric constant and dielectric strength?
So
Or they
dielectric
are same quantity according to you?
strength.
Dielectric constant. Yeah.
I've never come across that quantity before.
Dielectric strength is a field here at which dielectric will lose its dielectric property.
Huh.
For example, for air start conducting lightning, right? So it is
Uh,
300 kilovolt per meter.
yes, sir.
It is the field when operated a dielectric, the dielectric loses its dielectric property.
Hmm.
So are you in dielectric? Have you been through dielectric and electrostatics?
So they usually shelf dielectrics till we reach capacitance.
Okay, fine. If we are not through, then it's fine because there is much more than what meets the eye when it comes to dielectric. Then
Yes,
we
sir.
get back to the question. We'll be going to dielectric in the next class. Then we get back to this question. Now, in this question, what I'm going to do, Vasudev, is very simple. I have to first calculate energy. Energy due to both the fields. So what will it be? Half E1 plus E2 whole square? Half epsilon naught E1 plus E2 whole square?
This is well, I still have one doubt. This was the energy density per unit volume, right?
Correct.
So
Correct.
this is also energy density per unit volume.
Exactly.
So, yeah, how?
Now you know what to do, right? Did you get it?
Is it, okay, no, no, no. How did we get from sigma to E? I don't think you answered that question.
Just write the value of E, Nadir. 1 by 4 pi epsilon naught. Write the value of E.
Okay.
1 by pi epsilon naught Q by R.
1 by 4 pi epsilon naught Q by R. Okay.
Yeah, just to get you. Sigma is 4 pi R square. Cube 1 by 4 pi epsilon naught Q by R square. R square. That'll be R square field, right?
Okay, okay, Q by R squared. Yeah,
That
okay.
gives me sigma, right? Sigma by epsilon naught.
Okay, so that gives you sigma by epsilon naught. So E
Right.
squared should be sigma squared by epsilon naught
Exactly.
squared.
Um,
So, I mean, so we should be replacing
epsilon naught is
sigma.
up, dear, not down. Epsilon naught is up.
Okay, that
Epsilon naught
was
is
what.
numerator. Numerator.
Here.
Yeah, yeah.
Okay, okay, fine, fine, fine. That was what was confusing me all this while.
Half epsilon naught E square.
Yes, fine.
Right, dear?
Okay.
Now tell me, what will I do? I'll say that there are two fields. So energy density will be epsilon naught by 2 E1 plus E2 whole square, right?
Let's see.
Vector, vector,
Epsilon naught by
vector.
2. Yes, E1 plus E2 whole square.
Which we can write as E1 plus E2 dot E1 plus E2, right? Expand them, we get the answer, I presume.
E1 squared plus E2 squared plus 2 E1 dot E2. Okay, so that should give you
Yeah.
E1 E2 cos theta.
Yeah. We have been
Okay.
asked for E1 dot E2. We can keep in that form, no issues. Nevertheless,
Yes,
as you did,
E1 dot E2, sure. I mean, yeah, I am willing to do anything to get rid of cos theta because that thing's like you have no idea how that
yeah,
varies.
that's not no choice. Now, look at the first two terms. The first one to begin with. Half epsilon naught E1 square is self energy, right?
Okay. Okay, so self energy of sphere 1 plus self energy of sphere 2.
And the final is, the third one is energy of interaction. Because we are to get self energy added to interacting energy to get total energy, right? Into dV, we'll have to multiply it with dV, of course.
Yes, sir.
Get the energy per unit volume multiplied with dV will get me energy, right?
Yes, sir.
So the first one is, if I'm to integrate the first one, I'm getting half epsilon naught E1 square into dV, correct? That I can do for inside of the shell, first shell, correct? I'll be getting self energy of first shell, correct?
Yes, sir.
Similarly, I'll do for the second shell, I'll be getting self energy of the second shell, correct?
Yes, sir.
And whatever is left, I was aware of the equation which we began with is total energy, correct?
Yes, sir.
So whatever is left, that is half into 2 E1 dot E2 into dV, that will get me that will get me interaction, energy of interaction. Are you in agreement with it?
So
Two
this
part
is
shell, two
how
part
does
shell.
this represent energy of interaction?
See, total energy is what for us? Tell me. If I say total energy of a system,
Yes, sir.
then that'll be internal energy plus energy that you are gaining of interaction. That is the energy, right? Our energy.
Okay, so what we are saying is since this is the energy to the first sphere, this is the energy to the second sphere, this must be the
Yeah.
interaction energies. That's the line of reasoning
Yeah,
here.
correct, correct. Then only I can claim getting total energy, right?
Yes, sir.
Yeah. So that is the energy of interaction. And this energy of interaction is what we were to find, right?
Yes, sir.
So will you be able to work it out now? What will that term be? Epsilon naught E1 plus E2. Now, here is where the factor, they being very far, comes in play. The two shell being remotely kept will come in play now.
Yes, sir.
I have to find the equation for half into 2 epsilon naught E1 dot E2 dV, right?
Yes, sir. So this dV.
That is interaction energy. Once you got interaction energy, you can say what will be the interaction energy. What can be the interaction energy? Two points are kept very far from each other, remote from each other. One is Q1, the other is Q2.
Yes,
So
sir.
interaction energy will be 1 by 4 pi epsilon naught Q1 into Q2. But what it should be? Tell me. I'm asking. Rather, I'm asking. What should I? What it should be according to you?
So
You're aware of Q1, right, dear?
yes, sir. But I kind of. Okay, never mind. I got it. I got it. So like they're far enough, we can consider them point charges. So
Yeah, yeah, correct, correct. That is the issue over. If they are not far enough positive,
yes,
then it'll be based on configuration, which is getting first. See,
yes,
over here it doesn't matter because which one is getting first is not of much merit to us. That consideration, it doesn't merit a consideration. Why so? Because they are remotely kept.
yes,
Let me ask you: had they been kept close to each other or not that far? What would have then be the energy of interaction? Then what you'll say is it'll depend on which charge is getting the energy, which shell is getting the energy or charge first. Which cell is getting energy or charge first. It'll depend on it, right?
so how?
Because your configuration will accordingly change on the other one. They are conducting shells.
Yes, sir. But ultimately, in a static condition, regardless of how the charges were assembled or in
W1,
what order they were
no, no,
assembled,
no,
it
no,
should gain the same configuration, right?
W1. No, how are you saying it down? Let me ask you. One is they are not identical, right?
Yes, sir.
They are not identical. Now, if I ask you W12, can you say W12 will be equal to W21, whatever be the case? Let's say they are kept close to each other, right? And
Yes, sir.
I wish to find W21. I am filling one of the two first. I'm
Yes.
letting the first one get charged.
Okay, so you're
So will
charging
I
this
be,
one.
yeah. Will I be in a position to say that W21 will be equal to W12? No, I will not be. How will I?
Okay, so as you fill this, charges will get induced here, and this will also start
Yeah,
working on this.
yeah, yeah.
And then, okay, yeah, the order matter is fine.
Got it.
Yes, sir.
They being far, I can go ahead with this perception, and there is no fallacy in the same. The W12 will be equal to W21.
Yes, sir. So, but this is kind of um, violating the. Okay, well, then again, the changing electric fields. Okay, so never mind.
Yeah,
Okay, all right.
it's a good one. This one.
Yes.
And yeah, if you have any inkling on the capacitor, though I'll not be using it, but any inkling on capacitor, then I can take an interesting question on capacitor.
So I just know enough to get you through the APC electricity and magnetism exams.
That is what is required. So write it down. There is an uncharged shell. This drop of the case uncharged shell,
Yes.
and there is a charged shell, charge up to Q, capital Q.
Okay.
On my aim, or you can take two bodies, no issues. One body is charged to capital Q, and the other body is uncharged. Fine, yeah.
Yes.
My objective is to charge the uncharged body. Fine,
Yes.
by making a contact. Got it?
Yes.
And this process will continue. What's the process? You bring the charged one near to the uncharged one, you let them make a contact, and from the charged one, small q charge that has been given to you, small q charge flows when you make the first touch.
Yes.
What is left on the charge one? The initial charge being q. So the initially charged one, what charge you are left with is capital Q minus small q after making the first touch. Correct?
Yes.
And on the uncharged one, initially uncharged one, we are having small q, correct?
Yes. So,
And this process is now, what is to be done next is you will take and reinstate. The charge will be replenished. That means
yes.
the charge one is back to capital Q.
Yes.
You make second touch.
Yes.
and this process will continue.
Same queue every time?
Yeah, same Q. You are replenishing to Q. It's being
Yes.
replenished by a source. It's being replenished, capital Q.
Yes.
Okay.
All right.
And every time you make touch, of course, different charge will flow that you can get on your prudence. Correct.
So you said the same
What
charge
is the,
flows.
yeah. No, no, no. Same charge won't flow. Why will the same charge flow?
So, okay, I might have
Same
phrased my
charge will
question.
not flow.
Yes.
Q charge will flow. Charge flow will depend on difference in potential, right? Yeah.
Yes, sir.
Same charge won't flow, and you're not aware of what charge is flowing vis-a-vis touch. You're aware of only the first touch, getting it a charge, small q. Okay.
Yes, sir.
But being asked is the maximum charge up to which the uncharged can be charged.
Yes, sir. Max charge.
Maximum up to which the uncharged can be charged.
Yes, sir.
Pretty logic, nothing, no integration, differentiation. Pretty logic to work on.
Well, so, you know that this is going to be replenished to queue every time.
Correct.
So, wait, there was this formula for the capacitance of a shell, right? What was that? I've forgotten it.
It can be a shell, it can be a body. You can take a body. If you want a shell, then 4 pi epsilon r. You give
Okay.
charge Q, it gets a potential, and divide charge. The potential will be getting
Okay, I'll just take a general capacitance C.
yeah. General
So,
capacitance you may take C1.
okay, so C is equal to Q over V. So we know Q, right? So Q is equal to CV. So, okay. This is. And I've not solved a lot of questions related to capacitors, so my intuition with them is kind of substandard right now.
Are these being told to you, right? That when you bring two uncharged conductors close to each other, then what the distribution of charge outside, inside, they are known, right?
So two uncharged
Conduct.
sir?
No, let's say one conductor is 7Q, the other conductor has got charge 9Q, and you are bringing them close to each other.
Yes.
So how will the distribution change?
So
What will happen?
no, other than a very rough overview,
So,
I do not know that.
but presumably, okay, fine, fine. Okay. Just remind me whatever I'm telling so that it doesn't slip off my mind. These
Yes,
are
sir.
all of great import. It will not slip. Of course, I'll be taking it. Let's get the end to this one.
Yes.
Are you able to get to the end?
Yes, I like to think about it.
I like to think about it. Okay, fine. You take your time. No issues there.
Yes, sir.
Okay. Then I'll take that one. The other one. One is having 7Q. The other is having 8Q or 9Q. Let's say 7Q, 9Q. Two conductors, two bars you can take.
Yes, sir. Oops.
Yeah. One is
Okay.
7Q. The other is 9Q. And they
Yes.
are brought close to each other. So what will be distribution of charges on the faces? Four faces.
Yes, I think there was also a question about this in a module, and I wasn't able to approach it. Um,
UMI has gotten you three sheets, rather three conductors, and he has asked that what will be the case now.
yes, the module question was that, I suppose, like the three, and I think one of them is grounded also. Yeah, I don't know.
Anyway, the charges are fixed, so that will not make much of a difference when it's grounded. Grounded, I will take when I'll do the same. What I'll do is I'll ask you that when grounded, then what charge will flow. That will be a better question.
Yes, so potential must always be zero. You can work that out.
If you ground one of the plate, in fact, you can further it. In furtherance, you can say that one of the plate is then grounded. What charge will flow from Earth or to Earth?
Yes,
But that'll be after distribution. Initially, I'm not getting it grounded.
yes.
So what happens is outside will be charge added divided by 2 average. That is always the case. Can be proved.
So could you come again?
7Q, 9Q, hey, you can prove. Take a point. Take any point inside and field will be 0 inside, right?
Yeah, field should be zero.
Yeah. That'll get you.
So
If the
what?
charge is Q1, Q2, at least we know that the faces which are facing each other will have equal and opposite charges, right?
Equal and opposite? How?
Because they are facing each other, close to each other. All the field lines from one will cut the other one.
So you didn't tell me
Cauchy
they're like
Cauchy theorem.
close. Um, uh,
Cauchy theorem.
okay, so like are these like infinitely large plates, which are
No, not necessarily. They are close to each other. If
okay
they're not
equivalent
close,
scenario?
yeah.
Yes. So okay, in
There's
that
no
scenario,
point.
you'd have something like plus q minus q. Yeah, sure.
Even if you don't want to take that way, then you'll write two more equations. Not much.
Yes.
Plus Q minus Q taken, right? Then you know what will be charged outside. For the top one, it will be 7Q plus Q, and bottom one will be 8Q minus Q. Now you take any point and find field equated to zero.
Yes. And you can find these. Yeah. Okay.
So that is what we get from there. You'll
Mm-hmm.
get to see that outside will be same charge and the average. It will be average.
Yes.
It'll be 7Q plus 8Q by 2, and inside you can get in accordance, right?
Yes.
Now, furthering, as I said, let's say that you have Earth, one of the two, to be grounded, the two plates. One of the two plates grounded. Then what will happen? What charge will flow to Earth or from Earth?
This so which side have you heard? So that also makes a difference, right?
Maybe. I don't know.
I I would think it does. So if you have Earth this side, so okay, you'd have to make the potential of this phase area, but then the entire conductor is an equipotential. So I mean, yeah, okay. I don't think it depends where you put it. The entire conductor has to go to zero, right?
Yeah.
So yeah, this entire thing has to become a zero potential. Well, you'd have to work out some way to do that.
Want to work on?
So right now, I'm not feeling very bright about it.
That's the thing. Want to buy time on this?
Yes, sir.
Okay, fine. Can, no issues. Vasudev, we need to take a few questions on current. Have you been to current electricity as yet? Or you are, I think only one track runs with your batch, right? So you may not.
They've been wanting to split batches for quite a while, but they haven't come down to it. They say none of us have, like, not many of enough of us have the credentials to justify forming an Asachi batch.
So in that case, don't you feel that you all are moving slow because you all are not yet done with even dielectrics?
Yes, but like,
Little dielectrics capacitor that you are wanting, right? Even capacitor is wanting.
yes, sir. But right now they've finished the theory of gravitation. I think by the end of the week they would start current electricity.
Okay, no issues. In that case, I'll leave you with these questions.
Yes, sir.
Whether this is a very conceptual topic, and there are a lot than what meets the eye. A lot, I would say.
Yes.
Particularly, it'll be more to grapple when we are looking forward for how is a capacitor entering. Sorry, how is a dielectric entering capacitor?
Yes, there was a question in the AP exam actually. It
It's a
imparts
lot.
kinetic energy to the dielectric, and the energy of the capacitor itself goes down.
Basically, you'll get to know that there will be applicable if the plates are connected to cell, then F will come out to be du by dx. And if they're not connected to cell, it'll come out to be minus of du by dx. It's about comprehension. How do we get du by dx plus du by dx and minus du by dx? We'll be studying about it. Just letting you know that there are good stuff on electrostatic incoming.
Yes, sir.
Then you have a question in Fruitov, tried. This is easy, it can be tried. The shell is given to you and they have they call lobule of angle theta. That means a shell, a hemisphere, make a hemisphere and just make a lobule. That means one angle is theta, the other is pi minus theta. Okay, dear?
So, like, are you talking about solid angles?
No, it's not on solid angles. Make a hemisphere
Yes.
and just cut it.
Oh, cut it like from the top.
Cut this hemisphere, yeah, cut it with an arc. Draw an arc.
Okay, okay, all right. So you would get something like bend,
Theta and pi
pizza
minus
slice.
theta. Yeah, this slice. Yeah, correct.
Yes.
It'll be theta and pi minus theta, right?
Yes.
Find the ratio of field that they will produce at the center.
Okay.
It's a very interesting question. See, total will be sigma by 4 epsilon naught, right? Known that if not good, if not known, you can find it out. If I'm in terms of the hemisphere being asked, then sigma by twice epsilon naught. And if the angles are given to you, then they get in the ratio of angle. It's a very good question, Olympiad question, which is there in Pluto.
Yes, sir.
Okay?
Yes,
Much of
sir.
mathematics involved in it, though the end result is very amicable and understandable. Why did we get and how did we get? It's all on symmetry, and it will be very sundry when you are talking of examination of lesser repute,
Yes,
even
sir.
mains. It'll come
Yes, sir.
handy, right? Yeah.
Yes, sir.
Just ratio, tan theta, sin theta, just check once what you get. Okay? Okay, dear?
Yes, sir. What about the math classes?
Math classes, I was trying to figure out how can it be arranged, but I'm not getting some of the time with you. Can you get me morning time, dear? Any day?
Some Sundays.
Sunday? Yeah.
Sundays I
Sunday
can.
will
Oh, but then again, they've started these SRG classes on Sundays where they discuss the SRG paper.
that is
uh,
it was Thursday was my because going to me it didn't get realized last Thursday, so I take the ownership. It was me as I was traveling, so it didn't get realized. They kept on waiting for my call.
yes.
There was a fallout, but if you get me any other day, then I'll look forward for
So in the
realization.
mornings, it's literally impossible because I need at least 70% attendance in the college, and they look very serious about it this year. Last year they weren't. I mean, lots of people still got passed even though they attended a day or two. But this year they do seem serious about it, and I do not want to play with them. So yeah, I'm not skipping college.
No, see, anyway, the person who is going to teach you will be teaching the basic of permutation, combination, probability, Mr. Gupta, and he'll be taking you through few questions.
Yes, sir.
Majority of the questions I'm to get you, and we are also to deliberate. I'll also be partaking.
Yes, sir.
Majority of the Olympiad questions.
Yes, sir.
So I'll partake in his class, and I'll be furthering with questions later.
Yes, sir. So I had this question. The PRMO, I guess it's sometime in August or September. Would you be able to fast track a short prep course for that?
Yes, of course, I'm looking forward to it. Of course, I will.
Yes, because I'll
Of
be
course, I
honest. I've been preparing on and off for 4 years, and my personal confidence is not very high. Um,
Is it out? Is the is it's not out as yet. Yesterday only I was discussing with my kid.
yes, sir.
So it's supposed to be out in the month of the form filling. It's supposed to be out in the month. NSE, JS, and PRM both we are looking forward for.
Yes, sir.
I'm getting a little bit exhausted here. I've got message. Sure, we'll wrap it up. We'll wrap it up. We'll speak about it later.
Yes, sir.
Okay.
Good answer.
Please share the video with me here.
Yes, sir, I will. How do you want me to share it to you? Do you want me to upload it to a drive, or is a temporary link like Smash okay?
Which will be better for me to download. Easier for me to download.
So Smash downloads it faster, but it'll only be available for 7 days.
Gosh, I don't. Yeah, that's fine. 7 days. I'll be doing it maybe tomorrow. Today I
Yes,
won't be.
it's very simple. You just go click download to get it.
Okay, fine. That will do. Okay.
Yes, I'll send it to you.
Thank you. Thank you, dear.
Good
Bye.
night,
Take
sir.
care. Good night. Dear.